Okay, in 8.4, okay, we're going to be doing division and multiplication of rational functions. So let me show you how to do this in the context of a homework problem. Let me start with number 3 on page 577. This was one of the assigned homeworks. The first step when we do these problems is factoring. It will always be the first step. Our goal is to try to simplify these uh, types of divisions by factoring and then looking for opportunities to cross out. So it's important that your factoring skills are in good shape here, otherwise this could be a bit difficult. If we look at the numerator, we're saying, can we factor it? Well, we look for two numbers that multiply to 14 and add to -9, and those numbers do exist, -7 and -2. And so we factor the numerator. In the denominator, we look for two numbers that multiply to -14 and add to -5, and we can factor our denominator as well. After you do all your factoring, and in this case we fully factored, then we look for crossouts. Terms that are identical can be crossed out. When I say terms, I mean this whole thing is a term, not the 7 with the 7, but the x minus 7 to the x minus 7. No pluses or minuses between the terms. The terms themselves are contained in the parenthesis. We can cross that out because they're the same. It's the same as 1 over 1, 5 over 5, 6 over 6. Anything over itself is 1. And that leaves us with our answer, which is that. Let's try another one. Let's move on to, we'll say number 9. In number 9, we're given x squared minus 11x plus 24, and we're asked to divide that by x squared minus 3x minus 40. First step, factor in the numerator, two numbers that multiply to 24 and add to -11, and those numbers do exist. Go ahead and write those right here. In the denominator, we're looking for two numbers that multiply to -40 and add to -3. Those numbers exist as well, x minus 8, x plus 5. Now we look for cross-out opportunities. We have an x minus 8 and an x minus 8. Those can go, and we're left with an answer of x minus 3 over x plus 5. Okay? And that's really how all these problems work. Number 13, you'll have to remember the difference of two squares as another factoring method. In number 13, x squared minus 36, you need to remember that that's x minus 6 times x plus 6, difference of two squares. In the denominator, two numbers that multiply to 36 and add to 12, that's x plus 6 and x plus 6. We can cross out those, and we're left with x minus 6 over x plus 6. And that's basically how those problems work. Then starting in number 25, we're doing problems that actually you've done before. So for example, in 25, this time it's not about factoring, it's more about laws of exponents. Okay, it's much more about laws of exponents. This problem, you've done something similar. We have, when we multiply, we add the exponents. When we divide, we subtract. So in this problem, what I'll do first is I'll multiply across the numerator and the denominator. In the numerator, we have the 48. I have x to the 5th and x squared to make x to the 7th. I have y cubed and y to the 1st to make y to the 4th. In the denominator, I have a 6. I have x cubed. I have y to the 4th and y squared to make y to the 6th. Now we'll do division. 48 divided by 6 is 8. X to the 7th over x cubed. 7 minus 3 is 4. I subtracted the exponents. Y to the 4th over y to the 6th. Subtract exponents. 4 minus 6 is -2. But I cannot leave a negative exponent, so I'll go ahead and I'll move the y to the -2 term down to the denominator as y squared, and that's your answer. So that's really all you do when it comes to division and multiplication. Now there is another flavor of that. More advanced problems in the second night of homework. Let me just show you those briefly. If I look at number 31, for example, in number 31, you're given x squared minus 3x minus 10 over x squared minus 2x minus 15 times x squared plus 10x plus 21. We'll just pretend that's over 1. It's the same process. We need to factor everything that we can. So we factor this term, two numbers that multiply to negative 10 and add to negative 3. We'll go ahead and get x minus 5 times x plus 2. Two numbers that multiply to negative 15 and add to negative 2. Yep, those exist as well. Now we go to this term, two numbers that multiply to 21 and add to 10. We have numbers for that, 7 and 3. Okay, and we follow the same pattern. We look for crossouts. Well, we have this can cross out, and we could even cross out this x plus 3 with this x plus 3. Okay, and all that leaves us is with x plus 2 times x plus 7. That's your answer. So all of 8.4 relates to doing this type of work. There's only one other type of problem, and I'll just show you that briefly. I'm not going to solve the whole problem. I'll just set it up for you. In 35, you're given 8x squared y squared z over xz cubed divided by 10xy over x to the 4th z. When you see it divided by like this, that's like multiplying by the reciprocal. So rewrite this problem as a multiplication, but now add the reciprocal. We'll make it x to the 4th z as the numerator and 10xy as the denominator. And now you solve it just like we did this problem right here. So whenever you see a division problem like this, turn it into multiplication by flipping this term, taking the reciprocal basically, and then following laws of exponents. So that's how you do 8.4. Good luck.